So this is some material from Unit 7 and 8, Formulas and Measurements. We are looking at Box C here, Optimal Area and Perimeter. And if you're following along with this lesson, what you're really going to need is the page with the tables on it that goes along with it. So if you're watching this lesson online, you better follow the link to print it out, and then you can take notes as you go along. So what do we mean by optimal area and perimeter here? Well, these kinds of questions are what we call optimization questions. And what we're doing in optimization questions is we are asked to find the maximum or minimum possible value for something. Okay, sometimes it's a maximum, sometimes it's a minimum. And usually we have something else that we need to keep fixed. So there is something that stays fixed and something else that we want to find the maximum or minimal possible value for. In the questions that we're going to be doing, we are going to be looking to find either the maximum area or the maximum perimeter, or the minimum perimeter, or the minimum area. Okay? Okay. So here's the question we're going to work on first. This is a question involving optimizing area. A farmer wants to create a rectangular animal pen. He has 32 sections of fence. Each one of these sections is 32 meters long, and he's going to use these sections to build the fence around his animal pen here. What should the dimensions of the pen be to maximize the area here? So a good thing to do in these kinds of questions is think about what is staying fixed in this question and what is being allowed to change, or what is variable. The thing that is being allowed to change is usually the thing that you are trying to find. So in this question, we are trying to find the dimensions of the pen. Basically the length and the width. Okay. So those are the two things that we can change about our pen. What is not changing is the amount of fencing that he has. He has 32 sections of fence. This is the part that is staying fixed. Now if you think about making a fence around the outside of a pen here, something like this is our rectangular pen, we're using these 32 sections of fencing to go around the outside. So saying that he has 32 sections of fence is giving you information about the perimeter of this rectangle that we're trying to build. So what you've got is you've got this table here. And one of the ways you can approach these questions is to think of all of the possible, sort of a list of possible rectangular shaped pens that our farmer could make here, changing the width and the height, but keeping the perimeter fixed as you do this. So I've sort of made a list here of sort of numbered all of the possibilities we could have. A good way of starting this is to think, okay, what's the smallest possible width I could have here? And because our fencing comes in 1 meter sections, the smallest amount I could have for the width would be 1 meter. This would be a pen that looks really long like this. My width would be 1, and of course, my width would be 1. If my perimeter is staying fixed at 32, okay, what does my length have to be? It has to be 15, because we know that the formula for perimeter here is 2 times the width plus 2 times the length. So if our perimeter is going to be 32, 2 times W is 2, which means we have 30 to split between these two sides. And then we can use our width and our length to calculate our area. Area is length times width, so 1 times 15 gives us an area of 15. Well, let's say we make the width a little bit longer. Let's say we make it 2 here. Okay. So now, what is our length going to be? Well, from our perimeter of 32, we subtract 2 for one width, and then another 2 for another width. That leaves us with 28, which we have to split evenly between our 2 long sides. That's going to give us a length of 14 here. What's our area going to be? Well, length times width, 2 times 14 is 28. So notice that our perimeter is staying the same, our width and our length are changing, and our area is changing each time as well. And we can keep going on like this. We can make our width 3, our perimeter would stay at 32. Let's see, if we do 32 minus 3, we get 29, minus another 3 is 26. Split that between our two lengths, and we get a length of 13. To find our area, 3 times 13 is 39. So I'm just going to stop things right here, and I'm going to get you to try to fill in the rest of this table. And I think you've noticed that there's a bit of a trend here in our width and our length. Okay? So follow the trend in the width, follow the trend in the length, keep your perimeter fixed. It's going to be 32 every time, and then calculate what your areas are going to be. So what we can see now is, if you got your table filled in, is if we look at our areas, we notice that our areas start off small. They get bigger, 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 bigger. Then they get smaller, 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 smaller. So there's a point in the middle where we have the maximum possible area. That is right here. I didn't mean to do that. It is right here when our area is 64. Now, what are our length and our width when our area is 64? Well, our length is 8. Sorry, our width is 8, and our length is 8. Okay? So now we're starting to answer these questions on the next page. What are the dimensions, sorry, at the bottom of the page, what are the dimensions, length and width, and the area for the rectangle with the maximum area? Well, the length is 8 meters, the width is 8 meters, the area is 64 meters squared. Now, describe the shape of this rectangle. What kind of a rectangle do we have here? If its length is 8 and its width is 8. It is a square, yeah. Okay. So among all the different kinds of rectangles you can make, the square is kind of the optimal rectangle. It has the maximum area for a given perimeter. So we can apply this concept even without making the table here. Predict the dimensions and maximum area of a rectangle with a perimeter of 60 meters. Well, we want to take this 60 meters that we have and make a square with that perimeter. Well, we know that in a square, all of our sides have the same length. Well, I'll just say S, 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 S. So we want to take that 60 meters, divide it evenly between our 4 sides. So each of our side is going to be 15 meters. Now, if we know each of our sides is 15 meters, we know what our area is going to be. Our area is length times width, 15 times 15, which, punch this into our calculator, is going to be 225 meters squared. Okay. Makes sense. So we just make it into a square, and we figure out what the lengths of our sides are. Okay. Let's try the question on the back here. Similar sort of question with a small change in it. This time around, our farmer decides that he's going to use, or she's going to use, an existing stone wall as one of the walls of the animal pen. Okay? This means that he will only use the fencing on 3 sides of the rectangle. Now what is the largest area he can enclose? So let's draw a little picture of what's going on. This is the stone wall right here like this. So it's already built. He doesn't need to use any of his fencing to build that. And he's going to build his animal pen in a rectangle like this. Okay? So let's just label this width, and length of our rectangle here. Okay? The fencing, he still has 32 meters of fencing here. This is the amount that is fixed. Okay? But now, this 32 meters only, instead of being the entire perimeter, is just one width, one length, and another width. So in this situation, 32 is width plus length, or 2 widths plus 1 length. Have to always add up to 32. This is what is staying fixed in this question. We can change the width and the length such that 2 times the width plus 1 times plus 1 length always adds up to 32. Okay. Well, let's see how this works when we start filling in our table. Okay. And again, I'll just sketch our little diagram up here, just so I've got it. Okay. So we'll do the same thing we did before. We'll start with a width of 1. We know that the sum of the lengths of the 3 sides has to be 32. So if our width is 1, what does our length have to be? Well, we've got 1 for one width, 1 for another width. So we take those 2 off, and we're left with 30. So I can use all of that 30 meters to be my length. Remember, the sum here is width plus length. 1 plus 1 is 2, plus 30 gives me 32. And then I can calculate my area. 30. 1 times 30. Then I can make my width a little bit longer. Bring it up to 2. Now let's see. 2 plus 2 gives me 4. So what do I have to add on to that to get up to my 32? Well, I've got to add on 28. 2 plus 2 plus 28 gives me 32. So what's my area going to be? 2 times 28, 56. And I can keep increasing my width a little bit here. Everything always has to add up to 32. And let's see, 32, let's see, 3 plus 3 is 6. I subtract that 6 from 32, and I get 26. So then my area is going to be 3 times 26, or 78. Length times width. So now I think you can start to see the trend here. Our width is going up by 1 every time. Our length is going down by 2 every time. So take a couple minutes here, fill in the rest of this table, and think about those questions at the bottom of the page. So by now your table should look like this. Be sure to double check the values that you have in the area column, and it's the areas that we want to look at. So when we look at this area column, we notice the same trend that we saw before. Our areas start small, they get bigger, 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 then they get smaller, smaller, and smaller. So at some point right in the middle there, that area is going to reach its maximum value. And its maximum value is right here at 128. Now the question at the bottom asks us what dimensions of the rectangle, what are the dimensions of the rectangle with the maximum area? Dimensions means width and length. So our width is going to be 8, and our length is going to be 16. So width equals 8 meters, length equals 16 meters, and our area was 128 meters squared. Second question here, does the stone wall allow you to enclose more area? So this is asking us to compare what we did in the first question with what we got in this question. Here we're enclosing 128 meters squared. How much area could we enclose when we had to have 4 walls around the outside? Well, if we flip our page over, we see that we had 64 meters squared. So the short answer is yes, it does. We can enclose more area if we only have to make 3 walls than if we have to make 4. How much more, though? It is double, yeah. So we can enclose twice as much area. Okay. Is there a relationship between the length and the width of the enclosure with maximum area here? So look at our length and our width values, 8 and 16. How are these two things related to each other? Is there a relationship there? What do we notice? Yeah, our width is 1/2 of our length. What about our length here? Our length is 16. How much fencing did we have available? We had 32 meters. 16 is half of 32. So our length is half of the total fencing. And this is always going to be true when you're enclosing three sides, and that 4th side is already given to you. So we can apply this even without doing the table. Suppose he has 60 meters of fencing to work with. What are the dimensions of the rectangle with maximum area? Well, our length should be 1/2 of the total fencing. So our length should be 1/2 of that 60, or 30 meters. Our width should be 1/2 of our length. So that should be 1/2 of 30, which is going to be 15. And what's our area going to be? Well, area is length times width, 30 times 15. We punch this into our calculator, and we get 450 meters squared. Now, as a check on this, we should make sure that this number that we get here, 450, is twice as big as what we got when we had to enclose 4 sides. So let's see, what's half of 450? 225. We flip the page over, or we go back a few slides here, and we see that, yeah, when we were enclosing 4 sides, we had an area of, maximum area of 225. Okay? So once again, the area that we can enclose when we're enclosing 3 sides is twice as much as the area when we were enclosing 4 sides. And that's optimizing area.